Hola, buen día a todos. La verdad que es un honor y a la vez una gran responsabilidad, ¿no? Pero un poco nervioso abrir la ECO, porque en principio somos un village bastante joven. No yo ya tengo mis canas, pero empecé la ECO ya desde 2008, creo, en la época que se hacía en el Borges, eran las Galerías Pacífico. Que ayer contaba que me habían robado la cuenta de Facebook ahí. Pero bueno, pasa. Bueno, después de muchas idas y vueltas, esta keynote es muy importante para nosotros porque muchas de las charlas que dimos en nuestro village a lo largo de los años, siempre hablamos y hacemos énfasis y lo importante que es la privacidad, el anonimato, y lo que la comunidad aporta a eso. Y después de 2 largos años de encuentros, de charlas, inclusive, bueno, sin saberlo, también hay argentinos mismos que trabajan y colaboran en esta comunidad. Pudimos traer a Roger Dingledine. Come here. Roger es cofundador de Tor y uno de los desarrolladores importantes y principales de Tor y que tanto nos da, ¿no?, para nuestra comunidad, y por eso es tan importante tener de primera mano lo que venimos contando siempre de tercera mano, ¿no?, de lo que investigamos, las herramientas que usamos y demás, y está bueno tenerlo acá porque no solo es importante para aprender de lo que es el proyecto de primera mano, sino también para desmitificar muchas cosas y por ahí que están demonizadas del uso de estas herramientas y de lo importante que son, no solo para la comunidad hacker, sino para toda la sociedad. Así que bueno, un fuerte aplauso y los dejo con él.
Thank you. Okay. Hi, everybody. I'm Roger Dingledine. Buenos dias. That's most of my Espanol. So thank you for tolerating the English that I will try to use. Soon these are almost my slides, but they're not quite my slides. Okay. That's why we tested it early. Okay, I'm gonna, okay. I'm going to start it again. Yep, that works. Beautiful. Okay. Also beautiful. Except the strange lines, but the strange lines are good enough for me. They're good enough for you. Let us... It works. Maybe. Yes. Okay, close enough. Okay, hi everybody. I'm Roger, and I'm going to tell you a little bit about the Tor network and the Tor project and the Tor community. I'm going to try to smash 3 different talks together. First of them is how Tor works and on what Tor is. The next one is the censorship side of things, and the third one is the onion services side of things. And it seems like we might have some blinking slides throughout. Maybe they're trying to fix it in the back. But let us begin, and we'll take it from there. So. The first thing to think about is, what is Tor? Tor is a lot of different things. It's an ecosystem of tools out there that try to provide privacy and safety and security for people. It's also a nonprofit organization. It's a company that collects money from funders and tries to help build better Tor and help the world have more safety and training and so on. And then the third piece of what Tor is the community around the world of volunteers who are global and trying to teach people about why safety is important and so on. So it's a bunch of different pieces. Most people know Tor by Tor browser. It's the most popular application that people use with Tor, but there are a bunch of different things that you can do with Tor that I'll get into in a bit. So the first question from a security perspective, we're at a security conference, is what's your threat model? What are you worried about? What attackers are you worried about? So we've got Alice over here, and she's trying to browse the web to some destination Bob, some website, and where can the attacker be? Maybe the attacker is watching Alice's local network. Maybe they're on the Wi-Fi right here, spying on all the people who are trying to use the network and learning what they can about them. Maybe the attacker is somewhere in the middle of the network. Maybe it's AT&T or Deutsche Telekom or NSA or some large adversary that gets to watch a lot of the internet. Or maybe the attacker is watching the destination. Maybe they're watching WikiLeaks and they want to know who the users are who go there so they can go arrest them or something. Or maybe they are the destination Bob. Maybe it's CNN.com and they want to look at all of their users to figure out where they're coming from so they can advertise to them better. So there are a bunch of different pieces to that, and we can't solve it if the adversary is in all of those different pieces. But one of the important things to realize here, things to keep in mind, anonymity is not the same as encryption. You should use encryption, but even when you're using encryption, somebody watching your traffic still gets to see who you're talking to, when you're talking to them, how long you're talking to them, and that metadata is what people use to track down who is interesting. Nobody tries to break the encryption anymore. It's all about, let's build a social graph of who's talking to who, find out who's in the middle, and then we can break into their house and steal their laptop or something like that. So how many people here recognize creepy NSA guy from a couple of years ago and his phrase, "We kill people based on metadata"? And he's not trying to brag or threaten, he's just stating a fact. He's saying, look, we the NSA, use metadata to decide where to drop the bombs. That's just how it works. So part of the goal of Tor is to give you control over who gets to see your metadata. And that way you don't have to worry so much about who's watching and what they're going to do. So there are a bunch of examples recently of topics that we've been arguing about in the global politics world. We've got here Attorney General Bill Barr in the US asks Facebook to stop their plans for end-to-end encryption. And they've got some terrible phrase, which I'll read when it comes back. We're writing to request that Facebook does not proceed with its plan to implement end-to-end encryption without making sure that there will be no reduction to user safety. And this drives me nuts because basically the US government is saying, let us make sure that you do not add any safety to your users until you can prove that there will be no reduction in safety. And not giving people encryption is exactly why they're unsafe in this situation. And that article was 5-6 years ago, but here's one from 2 years ago. UK urges Meta to do the same thing, to not have end-to-end encryption. So this is an ongoing thing where major governments push companies into being insecure. And there are all sorts of strange side effects from that. Here's one. Sorry, you can only read the slides briefly, but it is what it is. So here's an example where the FBI went to Google and asked Google who had looked at which videos. And apparently the way it worked is they were trying to bust some bad guy, and they sent that person a YouTube link, and then they went to Google and said, tell us every single person who looked at that video. And I don't know whether Google answered, but that is a terrible situation to be in. I don't want to be in a world where there's a huge company and they have all the data and maybe they promise not to reveal it, but it's worse than that. So that's a situation where a big company having your data is itself a problem. Looks like they are, either they're messing with it or it's getting worse. Maybe I'll unplug from the slides and keep going. So another example, a couple of years ago, there was a woman in Nebraska in the US who was, I think she was 16 or 17 years old, and she got pregnant and was thinking about having an abortion, and she talked to her mother over Facebook Messenger to discuss whether to have an abortion. And Facebook turned over that data to the authorities who are now prosecuting her for wanting an abortion. So that is my country this year, and my country seems to be getting worse as time goes on. So that's an example where if Facebook didn't have that data, then they wouldn't have been able to turn it over to the authorities. And then there's a more, I used to grab screenshots of interesting articles to show examples of why metadata is important, but this year it's just a new article every day of terrible things happening in the world. The one that happened a few weeks, like a week ago, there's a company in the US called Flock that has 89,000 traffic cameras, so they record all the cars going everywhere. And apparently a woman in Texas had an abortion and then went somewhere else, and the police used Flock to figure out where she was going and who she was. And they said it was for her safety, but the reality was that they were thinking of prosecuting her for wanting an abortion. So that's also the world that I live in these days, and it's another great example of why I would like some sort of safety in the world that gives people control over their own situation. Thank you, whoever fixed the slides in the back. This looks much better now. Okay. So I actually only use the word anonymity when I'm talking to my family and people who don't understand the internet. When I'm talking to my parents, I use the word privacy. When I'm talking to companies, I use the word communication security or network security. Imagine you're investigating patenting something and you don't want your competitors to watch what you're doing on the internet to learn that. And then when I talk to governments, it's not anonymity, it's not privacy, it's traffic analysis resistance. Because you go to a government and you say, I have a privacy tool, and they say, we don't need privacy. And you explain that you've got security, and they say, oh, we have all the security we need. We don't need any more. But you say, this is a way to let you resist traffic analysis. You can send your diplomat to Israel, and nobody will know that it's your diplomat when they watch the hotel's internet connection. So that's the sort of thing that governments, it's the same sort of security properties, it's the same network, but different users use it for different reasons. And then the fourth category that we'll talk about a bit at the end is the reachability, the human rights. I'm in Vietnam and I can't reach the New York Times or BBC, so I want to get news or tell people what's going on in my country. So part of the goal of this is to blend all of these different types of users into the same anonymity system, into the same Tor network, because you can't, if you're an Egyptian activist and all the users are Egyptian activists, it's not going to keep you safe. And if you are talking about cancer and all the users are talking about cancer, then people are going to know why you're using the system. So you need the Egyptian activists and the cancer survivors and the police and the ordinary users all in the same network so that they can protect each other. Okay, so how do you actually build one of these? The easy answer is you have some, like the VPN model. You've got some central company in the middle, and all the users go to it and then browse the web through it. And that's great, except what happens if that central company in the middle turns out to fail? And it always starts with, we promise we won't look at your traffic. Okay, we look at your traffic. We promise we won't write down what we see. Okay, we log everything, but we promise we won't tell anybody what you do. Okay, well, of course we answer subpoenas, but what do you expect? And then we sold the company and we sold the data set with it, and we're a company, what do you expect? So the problem with the centralization is it always turns out that that company in the middle, even if they mean well, even if they start off meaning well, that centralization is itself a problem. And I'll tell a couple of stories in the afternoon session about talking to law enforcement where they basically reinforce this notion that the centralization is really dangerous for users. And it's worse than that, because even if the central VPN really does plan to keep you safe, maybe they're in Switzerland and somehow Switzerland is magic, so they never answer questions. Even in that case, they still have a network connection to the rest of the internet. And somebody watching that network connection, Deutsche Telekom, Swiss Intelligence, whoever, gets to see all the traffic coming in and all the traffic coming out, and they can match it up by timing and volume. So even if your centralized VPN company is somehow telling you the truth, they're still centralized. And the fact that all of your data is in that place means that a lot of different groups have the ability to match up who the user is with what the destination is. So I want something that's based on distributed trust, decentralization, so there's no single point that gets to learn both this user and that destination. So the goal of Tor is we have something like 7,000, 8,000, 9,000 relays now around the world, and you route your traffic through 3 volunteer relays, and as long as they don't collaborate to match up this user entered the Tor network and that destination was reached at the same time, then you're safe. So it's not perfect, but it's a lot better than the centralized model. Okay, so we did some, now let me put on a different hat, the social scientist hat. We talked to some actual users and asked them, why do you value Tor? So I've got 2 examples here. One of them is the one everybody expects. I use it. I'm a political activist. In my early years, I was more public, and now I'm being persecuted for this. Tor allows me freedom to publish my message to the world without being noticed and without people tracking me down. So that's what we all think of when we think of anonymity. But then there's another example that a different user gave us. I'm a doctor in a very political town. Think Washington, D.C. or Brussels. I have patients who work on legislation that can mean billions of dollars to major companies. So when I'm researching the diseases that my patients have, of course I use Tor, because my job as a doctor is to actually keep my patients safe. So of course I'm not going to research cancer as soon as the senator leaves my office, because the ISP and the telephone company and the government agencies could all match that up. And then they can go blackmail the senator or bribe him or whatever they're going to do from there. So that's, and the doctor example is one thing, but a lawyer example is another good one, where if your job is to keep your customer actually safe, then you need to have your own safety, security, privacy while you're helping them. Okay. Looks like we're going in and out of slides again, so we'll see how that goes as the talk goes on. So there's another piece of the talk, which is the performance side of things. Tor is a lot faster than it used to be, and part of that is because we're adding a bunch of relays all around the world that'll have a lot of capacity. So the green line here is the capacity of the Tor network over the past 10 years or so, and the purple line is the load on the network. So they're both going up, yay, but part of the lesson here is the difference between these 2 lines has to do with how fast the Tor network is. So as long as we can keep a lot more capacity than load, then, because the reason why Tor is slow when it's slow, it's not that you're bouncing around the world or the speed of light is slow, it's that there are a lot of users using the system and not enough relays. So it's congestion inside the relays. You're trying to load your Facebook page while somebody else is watching a YouTube video over the same relays. So that's why we need more capacity. Okay, and then another piece of this to think about, how do you actually think about security when it comes to Tor? Like, how do you, if I give you this Tor network or that Tor network, which one's safer? And there are 2 pieces to measuring security here. The first one is diversity of where the relays are. At the beginning, the Tor network was run by me in Boston, and if you were able to watch the Boston ISPs, then you could track everything happening in Tor. And as we added more relays around the world, the set of people who were in the right position to see enough traffic to start doing analysis became smaller and smaller. So the diversity of where the relays are in the world relative to where the attackers are is the first piece of how to measure security. But then the second piece is diversity of why people are using it. I talked about that earlier for Egyptian activists or cancer survivors. We need a lot of different kinds of people who are using it for different reasons. And one example there, I always talk to some security person who's like, I don't understand how Tor still works in Iran. Don't they just find a Tor user and kill them and then keep doing it until nobody wants to use Tor anymore? And the reason that doesn't work is there are 50,000 people in Iran using Tor to see their dancing bunnies on their Facebook page. It's because Iran blocked Facebook and starts blocking YouTube and other things. Everybody installs tools like Tor to get around the censorship. So the average user in Iran is actually the average internet user. They're ordinary 20-year-old people who want to see the internet the way it was last year, and tools like Tor allow them to do that. So that ordinariness, the fact that they're just trying to go to Facebook just like everybody else, that's a security feature for this much smaller set of people who are actually trying to change their government from the inside. Make sense? Great. Okay, and then, so that was Tor at the network layer. I want to make sure that somebody watching my traffic doesn't learn what IP address I'm going to, the destination doesn't learn what IP address I'm coming from. But then there's a second layer, which is the application layer. So we start from Firefox, and we have a fork of Firefox called Tor Browser. And part of the challenge at the application layer, you all know about cookies, but there are all sorts of things like cookies, which languages you have, which fonts you have installed, which versions of which JavaScript, and all of these are cookie-like things that let people track and recognize you. They might not let you learn the IP address of the user you're attacking, but you can say, oh, that was that same person who had this browser fingerprint, and now we can watch them over time going to different websites. So part of the goal of Tor Browser is to make all the users look the same. And this private browsing mode thing is pretty confusing. DuckDuckGo did a study a couple of years ago asking people what they think private browsing mode is, and most people are wrong. Most people actually think it's what Tor Browser does. They think that it protects you from the website you're going to, your internet provider, the advertising company that tries to inject ads. Private browsing mode simply protects your hard drive from somebody walking up to your same computer after you've browsed for a while and using that browser to figure out what you did earlier. So it's only protecting a local user using your computer. It does no protection against network adversaries, websites, and so on. So the first lesson is a lot of people want what Tor Browser provides, so we need to figure out how to scale it to the point that everybody in the world can have it. But then there's also the education side of things. I found this awesome, sad webcomic a while ago where we've got Big Chrome saying, which website would you like to see? And we've got sad users saying, I don't want you to know what website I'm going to. And then Big Chrome holds up the sock puppet and says, how about telling Mr. Incognito? And the user's like, yay, I'll be safe, woo, I'll tell you everything. And this, basically, it comes back to the centralization. And this is what users think private browsing mode is doing. And hey, it's named private browsing mode. Why wouldn't it keep you safe? And the answer is it comes from a huge for-profit corporation whose business model is spying on you. So, of course, it's not going to keep you safe. Okay, so another key thing to think about, Tor, in terms of transparency, of course it's open source, of course it's free software, of course we have public research papers and design documents to say, so the open source is this is what we built. The design document is this is why we built it that way, and we've got specifications that say this is what we think we built. So now you can look at each of these and compare them and say, I found a bug in your code, I found a bad idea in your design, and that openness is really important for the world being able to help us build Tor and make it safe. And the other piece of that is we're publicly identified. Hi, I'm Roger, I wrote Tor, and part of this is building the community around the world of people who actually know us and understand why Tor is built the way it is and what safety it provides. And part of the challenge there, I always, when I say these things, there's always somebody saying, oh, haha, the anonymity people are talking about transparency. That's a contradiction. And the answer is it's not a contradiction because privacy is about choice. We choose to be public and open because that helps to build a stronger community, but that choice is the privacy that we have. We can choose who gets to learn about us, and we choose to be transparent and public because it builds a safer, stronger Tor. Okay, and there's a whole other talk I could do about this guy, and you'll notice the Tor sticker at the top. There were a lot of journalists who came to us and wondered if Ed wrote Tor, and so we spent a while teaching journalists. But the main point I want to make in this case, there are a lot of high-profile users who've used Tor, and in this case, Ed was safe until he decided to identify himself. So it's not that Tor has to keep you anonymous forever. It's that Tor should give you control about who gets to learn information about you and when they get to learn it. Okay, and then another debate that I'd love to keep having with a lot of people. A lot of people look at this and say, well, yeah, but what about bad people? There are bad people on the internet, and what if they have privacy too? And it starts off saying, well, yes, but there are millions of good people using Tor, so you need to balance the good people with the bad people. But really, it's not just a balance, because if you have a military, if you have a law enforcement group, if you have a lot of money, you're doing great on the internet. If you're the Russian mafia and you control the local police, you don't need things like Tor. You've already got your own safety through whatever you're buying. Whereas if you're a vulnerable blogger in Morocco, then of course you need something like Tor in order to be safe on the internet. So a lot of that, it starts with people who say technology is just a tool. Of course, it can be used for good and bad. But I look at that and I think that's the wrong way of looking at it. The right way is technology is inherently political, and you need to understand what changes in the world you're trying to make based on the technology you're building. And if you build centralized things, think Google Docs or something, then you're reinforcing the power structures for the huge companies. You're keeping the power in the middle. And if you build decentralized tools like Tor, then you're moving the power out towards the users. So think about the power structures that you're enabling or changing, because if you don't think about how the politics of your tool works, then you're going to accidentally just reinforce the existing power structures and give more power to Google and Facebook and various governments. Okay, so that was the first piece. That was how Tor works, what Tor browser is. The second piece of the talk is the anti-censorship side of things. So here's how the Tor website looked from various countries in the Middle East several years ago. So we've got surf safely. This website is not available in the UAE. And then down here we've got, sorry, the requested page is unavailable. If you believe the requested page should not be blocked, please send us your email address here so we can put you on the list of people who are unhappy about the censorship. And part of the weird thing here is you'll notice all these goofy people on these pages. They're not, hello, we're in charge, you can't. They're all cross-eyed with weird hair, and we've got the people down here in UAE saying, oops, you can't get to the website. Oops, we're fascists. They're trying to make it fun or funny or jokingly remind you, while also clearly being in the middle and saying, look, we're not going to let you get to that website. So at first, there were a lot of people using Tor to get around censorship. They block BBC, you install Tor, you can get to BBC, yay. But then the next step was, then they started trying to block Tor. And in most countries around the world, Tor still works, but in some places, you need what we call a pluggable transport. And the goal of the module is to transform your Tor traffic into some protocol that they're not willing to block. Like WebRTC is one example we'll talk about in a bit, and some destination that they're not willing to block. So that's either a website that is too big for them to block, or it's a bunch of different addresses that are not easy for them to enumerate. So the goal of, we have a bunch of different pluggable transports to transform your Tor traffic into something that will get through the block, and one of them is called Snowflake. The idea for Snowflake is to send your traffic over WebRTC. And one of the cool things about WebRTC, that's the protocol underneath Zoom and Jitsi and Signal Video and so on. So it looks like you're having a video chat with somebody. And the other cool thing is WebRTC is built into the browser. So in the old version of bridges and pluggable transports, you apt-get install this thing, and you edit this text file, and then you do a systemd restart. And if you understood those sentences, great. But in the new version with Snowflake, install this browser extension. And now you'll be helping people get around censorship. And we have 150,000 or something people who have installed the Snowflake extension in their browser, at work, at home, wherever. And that means that we can scale a lot better. And it's hard for attackers like Russia to build a list of all the snowflakes in order to block them by address. And this is relevant because when Russia invaded Ukraine, a few months before that, they did a lot of internet censorship in Russia. So we saw that before the invasion. Wait a minute, why are you blocking all these pieces of circumvention tools? And we had 6,000 users in Russia using Snowflake. And we were like, yay, it works. Look, the graph's going up. We've got users, woohoo. That turns out to be just this tiny little piece over here of what turned out to be a way larger population of Snowflake users 8 months later when Iran had a protest and Iran blocked a bunch of VPNs, they blocked many pieces of Tor, they blocked tools like Siphon, they blocked a lot of different things, and a lot of people were using Snowflake. We had hundreds of thousands of people over that weekend in Iran who were using Snowflake to get around the censorship. So there's a whole other version of the talk here, which is the censorship side of things. There are a couple of lessons that I'm still sort of trying to think through. So the censorship arms race is bad. China has billions of dollars that they're putting into learning how to block pieces of the internet, and we're not spending billions of dollars. We're 10 or 20 people who are excited to try to provide more safety and freedom in the world. So that's the first piece where there's an asymmetry. But at least in the censorship arms race, I try to send some traffic and it doesn't work, so I change something and now it works. There's a feedback loop where I know that I uncensored myself. But the surveillance arms race, I send some traffic, I don't know if the NSA saw me, I change something, I still don't know if the NSA saw me. So the surveillance arms race has no feedback loop. I need a new Ed Snowden coming out every week telling me what the NSA is watching for. And other than that, there's no easy way to know if you're doing it right. And the centralization of the internet makes it worse with Cloudflare in the middle, and they get to see so much. And we used to make gestures like this, you bounce around the internet, but actually there are only 5 cables under the Atlantic Ocean, and your traffic's going to go over one of those cables. So there's a lot, at every layer, the app stores, the Google and Apple app stores, at every layer there's centralization that makes it so your traffic is in an easy place for some adversary to look at. And yeah, for time, I'll skip a few things. The other key thing to think about on the censorship side of things, it's not, I mentioned China spending a lot of money, but the biggest problem in internet censorship is actually California companies and Italian companies and German companies who are, and Israeli companies these days, who are building surveillance and censorship tools and then selling them to whoever wants to buy them. So there's a sad story that I can tell later about a company in Sunnyvale, California named Bluecoat that built and operated the censorship infrastructure for Syria. And my country has laws against exporting tools like that to Syria, but that didn't stop them. So it's more of a problem these days because it used to be that Europe was kind of free. They wanted to seem like they were free. But then Russia Today, it's the equivalent of BBC, but made by Russia, started doing misinformation campaigns. And somebody in Brussels said, what we need to do is block RT.com. So they passed an EU-wide regulation saying that you have to censor this website. And now every country in Europe has to build and deploy a censorship mechanism so they can add this website to it. And some companies like Romania are like, yeah, I've always wanted to censor the internet. I'm gonna start with the website you said, but now I'm gonna add 1 million more websites because our goal is to keep our citizens safe. So part of the challenge there is all of these countries want to get in on censorship, even the ones that start off thinking that they're trying to be free. So as an example, Australia censors the internet. They've done it for 10 or 20 years now. England censors the internet. Sweden censors the internet. So imagine you're working for the foreign ministry and you want to send a delegation to China and say, you're not a very good democracy because you censor. And they say, look, we censor just like you do. We're keeping our citizens safe just like you're keeping your citizens safe. Why are you picking on me? Everybody blocks the internet. They might not say censors. So one lesson there is how do we how do we go to China and convince them if we can't even go to Australia and convince them? And it always starts with something. In Australia, it's think of the children. In Denmark, it's think of the people downloading movies from Hollywood. It always starts with some reason why they have to get together as a nation, and then it slips up into, I'm blocking abortion websites, I'm blocking Republican websites. So there's a slippery slope every time. Okay, so that was the second piece of the talk. And the third piece of the talk is on the onion services side. So everything I talked about so far was I want to build a path through the Tor network, and I'm going to exit from the Tor network to some website like BBC. But once you've got that anonymity circuit, the 3-hop building block, you can glue 2 circuits together, and now you can talk to people inside the Tor network, and you get a bunch of cool security properties. So this is how it looks in practice with a big base 32 thing as your address, blah, 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 .onion. And the cool thing about that blah, 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 .onion, that's the public key of the onion service. So by knowing the address, you can, inside Tor, it can check that you really are talking to a destination that knows the private key that matches up with that address. And that means you don't, how many people here know the word certificate authority, things like that? I see some hands, great. So on the web, in order to get your little lock in your browser, the website you're going to needs to have gone to 1 out of 400 companies around the world, each of which can claim that it really is Facebook or BBC that you're going to. Turkish Telecom is a certificate authority. So in Turkey, they can pretend to be any website they want to. China Telecom also is a CA. I bet there's one in Argentina. So the whole certificate authority model is really dangerous in terms of actually knowing which websites you're going to. I'm sure there's a talk here today or tomorrow on how to manipulate browsers into thinking they're going to a website when they're not. So the cool thing about onion services is you just get rid of that whole certificate authority model, and users themselves can verify that they're going to the right site. So you get a couple of cool properties, the self-authentication that I talked about, you get end-to-end encryption built in, and some other cool things like you can run an onion service without being reachable for incoming connections. So I can run an onion service deep inside the corporate firewall in a way that, that the sysadmins don't think any connections are coming in, but I'm still running a server because the connection comes in through my outbound Tor circuit. And you might know the onion service world from phrases like the dark web, and these weird iceberg photos keep showing up of that's the internet you know about, and oh my God, there's another 99 internets that you've never heard of, and the dark web is all scary, and that's where all the and I found this even weirder one recently. Like once you've got an iceberg metaphor, you might as well turn it into an iceberg skull metaphor. And there's some scary stuff down there. It started with the phrase deep web. It was made by search engine optimizers to say, there's a bunch of websites that Google can't reach, and pay me and I'll help you get higher on Google. And somehow it turned into dark web, scary. So I guess one version of that question, what would you think the biggest website on the dark web is? Which website out there has more pages, a larger website than any others? Maybe you've read some drug news articles or something. The answer is Facebook. Facebook is the largest website on the dark web. And this is because back in 2016, they did an internal study of their users and said 1 million people have connected into Facebook using Tor. They obviously want privacy. Some of them are in countries that block Facebook, so of course they want to use tools like Tor to get in. So we, Facebook, should clearly step up and do our part, offer an onion service so they can know that they're reaching Facebook, so they get end-to-end encryption. The users obviously want it, so let's step up and provide. So that was what Facebook's reasoning was. And since then, BBC set up an onion service, New York Times set up an onion service, ProPublica, Reddit set up an onion service. There are a lot of different websites that are setting themselves up on the dark web, not because it's dark, but because they want their users to have the choice about how much safety they have. And the really interesting example here, Cloudflare set up a bunch of Onion services. So every time you go to a Cloudflare-hosted site over Tor, they quietly redirect you to one of their Onion services. And this reduces load on the Tor exit relays because you never have to exit from the Tor network. You just go to one of these Onion services. And you get end-to-end encryption built in. You, the user, don't even have to see it's happening. And Cloudflare hosts 20% of the internet or something these days. So 20% of websites are on the dark web. What does this even mean at this point? That it's an ordinary thing with BBC and Facebook, and FBI.gov is hosted under Cloudflare. So FBI.gov is on the dark web. Like what does this word even mean at this point? And we were trying to figure out how to frame this in a way that makes sense. So here's how a lot of this is what Hollywood thinks. We've got Onion services, we've got bad people on the internet, we've got your private Facebook posts that people can't read, and they're all sort of dark webby together. They're all mashed together. But the reality, of course, is they're mostly different things. The Russian criminal people are doing fine. They don't need Tor. Your Facebook posts aren't the same as Tor. That doesn't make sense. And there are some people running Onion services. But so the first question is the Onion services the dark web? Because I thought it was the bad people. Or is it the bad people? Which would make sense. But then why are you talking to me? Because most of the bad people are elsewhere on the internet doing their bad things just fine. Or is the dark web your Facebook posts? And that doesn't make sense either, but it makes as much sense as any of the other definitions. And maybe it's that little intersection in the middle of bad people who can't be reached by Google who are also using Onion services. I actually talked to a threat intelligence company a while ago, and their analyst said, of course we have to crawl Tor to get our data set, but we don't find anything interesting there. The place where we find all the interesting stuff is our Pastebin Pro account. So they sign up for Pastebin, and every time some jerk in Russia wants to brag about how many credit cards he's gotten, he puts it on Pastebin, and that gets sent to that company. So all the good stuff comes from Pastebin, not even Tor in this case. And scale matters here. This is actually not to scale. The purple circle should be 0 pixels compared to all the bad people on the internet or all the Facebook posts out there. So yeah, so that I'd love to chat more about dark webby stuff. But Onion services are not just websites. There are a bunch of other tools out there that use Onion services, not for, I want to set up a website that's going to make somebody angry, but for the end-to-end security or the NAT piercing or the usability and so on. So one example is the Bitcoin network. Here's a graph of how many Bitcoin nodes, the equivalent of validators in Ethereum land, are available on IPv4 addresses, that's the black, IPv6 addresses, that's the sort of greenish, or Onion addresses, that's the purple. So the majority of the Bitcoin network relies on the Tor network for its reachability these days. And they did it for the reachability, so you can run your Bitcoin node behind a firewall, but they get all the security properties built in. Okay, and there are a couple of other examples that I'm going to skip for time so that we can get to chatting about whatever you want to chat about. So one example here is Onion Share. It's a tool that journalists use to pass files back and forth in a way where you don't have to set up a central server, you don't have to use Dropbox, you don't have to use Gmail. One person runs Onion Share, it spins up a little Python web server, it gives you an address like this, you send this address to your friend, they put that address into Tor browser, the file gets transferred, the website goes away, so there's no middle, there's no center that you can break into or send a subpoena to or collect data from. It's just actually the way sending files should have been on the internet. And another version of that is there's a chat app called Ricochet where every user is an Onion service. And this means, so if you're used to iMessage or Google Chat or Telegram or Signal or WhatsApp, they are all centralized. They all have a center. They know who the users are. They know who's talking to who. If it's end-to-end encrypted, they still know who you're talking to, how much you're saying, when you talk. So the cool thing about tools like Ricochet is there's no middle. There's no place to go to get that data. Okay, so there are a bunch of different things we worry about in the Tor world. I've tried to order these 4 by how common they are. There's always some person who says, I used Tor for a week to try to get around Putin's Secret Service, and eventually I screwed up and I didn't use Tor, and then they found me. And then the browser metadata. Tor browser tries to make all the users look the same, but it's hard to do in a way that's usable. And then people break into browsers over Tor, and I mean, who would run a browser on the internet these days? They're crazy, complex, vulnerable things, yet we all do. And then maybe the traffic analysis is an issue, but definitely the least of the big issues. The other thing I've been wrestling with, so I started the talk talking about end-to-end encryption and how governments are bullying Facebook about not deploying end-to-end encryption. We've got Apple, in this version of the crypto wars, where we're trying to let people have safety and control their own data, in this version of the crypto wars, Apple is on our side. That's a weird world to live in, because they're one of the huge corporations, but they've got a bunch of press people who are really good at changing people's opinion. And the sad version of this is that they don't actually care about your privacy. What they mean by your privacy is important is give me all of your data, trust me, I will keep you safe. But when it comes to PR and press and comms, they're doing a lot more work than I am at reaching everybody about the importance of keeping your data out of the hands of the advertising companies and so on. So that's a weird world to live in, but it is the world we live in. A last thought. EFF, Electronic Frontier Foundation, started a campaign a year or so ago to try to get more people running Tor relays at universities. We have relays running in Mexico City, but in terms of Latin America and universities, that's it right now. So we would love to have, if you're connected to a university, I'd love to chat with you afterwards. Maybe you're a professor or a sysadmin or a student, or one of those who'd like to help out. And please chat with me afterwards. We're up to 41 different universities around the world. So part of the goal is to show that momentum in order to make it not so weird for somebody to set up number 42 and 43 and so on. And universities are great places for Tor relays because of the education side, the research side, the community side. Okay, and I am nearly out of time, so a couple of things to ponder. First one, think about centralization. Think about how, when you're building a tool or you're using a tool or you're teaching your friends about a tool, where is the power going? Is the power going to the middle, to the company, or is the power going to the edges, to the users? And then help teach your friends, your family, your coworkers about the importance of privacy, especially in this world where it seems like everything's getting worse every week, every news article we read. So we need to help spread the word about why keeping your own control over your information is so important. And please run a bridge or a relay or a Snowflake, especially if you're at a university, but maybe otherwise. And then the last thing is I have another talk this afternoon at 4:15 in, I think it's Sala 2. So you can hear more about stories of me trying to talk to governments and law enforcement. And there's a particularly sad, weird, funny story about talking to the Russian mafia who were trying to attack the Tor network and bribe me to keep it vulnerable. So yeah, I'll see you there this afternoon. And I'm going to walk around in a bright green Tor t-shirt in between. Please come up and ask questions. I'm here to help answer whatever you want. Thank you.
Fuerte aplauso, gracias Roger.